Lesson 14, video number 3. We're looking at problems number 8 and 9 in this video. Now, they both follow the same kind of identity. This particular identity, I am not expecting you to memorize. It's just something that's nice that we can utilize, okay? Now, I want you to look at this specific form, okay, that we're given. I want you to look very closely at it while you're looking at it. This is a function of a form. A sine of x, b cosine of x. A and b are numbers. Those are not variables. Yes, they can change, but we're not changing them. They are a constant value that you will be given, okay? And it is supposed to be equal to the square root thing, a squared plus b squared, times the sine of x plus, now notice this is not a, this is alpha, okay? Where sine of alpha is equal to this thing and cosine of alpha is equal to this thing. Now, there's a lot of stuff going on here. The focus is specifically that I can take the addition of a sine and a cosine function, as long as they're the same angle, and write them as a single sine function. Now, this is huge in the ability to recognize a trig function, the addition or subtraction of them, as simply sine, okay? So what we're going to do with this is we're actually going to go ahead and look at the trig function that they're asking us in problem 8, in example 8, and we're going to rewrite it in this form, okay, utilizing this entire identity. So let me zoom back out here. And again, pay very close attention. I'm actually going to rewrite a lot of this information down, okay? So it wants us to take sine of x plus cosine of x and rewrite it as something of this form. K times the sine of x plus alpha, okay? So the first things we need to do is figure out what k is and figure out what alpha is. Well, remember back in our identity, okay, I always have a, the sine of x, plus b, the cosine of x, is equal to this number, square root of a squared plus b squared. Okay, that actually happens to be my k. That's square root of a squared plus b squared. Okay, this is times the sine of x plus alpha. Okay, and again, this is identical to what's written on this right here. Okay, up to this point, I've just copied that information down. Okay. With that being done, let me look very carefully at the stuff that I'm given. A is clearly 1. B is clearly a positive 1. If that's the case, that can give me my k value. My k value being equal to the square root of a squared plus b squared. Therefore, that's equal to the square root of 2. Okay, again, plugging those values in, I have a squared, 1 squared, plus b squared, 1 squared. 1 plus 1 is 2. Okay, so right off the bat, I can tell you that the sine of x plus the cosine of x will actually never go past radical 2 or go past negative radical 2. Again, this being the amplitude. So that's going to be the new amplitude of this new sine function. Okay. The next thing I have to do is determine what the heck is this alpha. Okay. Now, let me look at my formula here again, and I'm going to write down what they gave me. They gave me that the sine of alpha is supposed to be equal to b divided by a squared plus b squared. Likewise, the cosine of alpha is supposed to be equal to a over the square root of a squared plus b squared. So, with that being said, okay, what should the sine of alpha be equal to? Well, 1 divided by radical 2, yes? Okay, again, plugging in b as 1, and this being radical 2. Okay, what's cosine of alpha equal to? 1 over radical 2 as well. Well, if you're very, very good at remembering your unit circle, and remembering that we don't really like unrationalized denominators, we actually get that the sine of alpha is this, and the cosine of alpha is this. What does that mean that alpha must equal to? Okay, where on the unit circle do I have the point radical 2 over 2, radical 2 over 2? Again, that's what I'm going to go to, right back to the unit circle. Okay, what's the alpha giving me? I hope you guys have 45 degrees or pi over 4 radians. Well, if that's the case, going back to the original part up here, that's what my alpha is. So, what is this sine of x plus cosine really? It's radical 2 sine of x plus pi over 4. And we know how to graph that. So if I had asked you to also graph this function, you could. You're going to tell me it's going to be the sine function shifted pi over 4 in the negative direction. Yes? Okay, so back here at a negative pi over 4. And it's going to start low, go up, back down, and back over. Okay, ending at a certain value, have a middle value at a certain value, and our maximum point will be at a radical 2, and our minimum point will be at a negative radical 2. Again, if I asked. Which leads us now to example number 9. Okay, and again, make sure you remember to pause these videos and rewatch them if you need to. So, example number 9 says graph f of x equal to a negative sine of x plus radical 3 cosine of x. Well, if I follow the rules that I just used, this shouldn't be a problem for first changing this to be of the form k sine of x plus alpha. Okay? Again, that's what I'm going to want to change it to. First of all, k is supposed to be equal to the square root of a squared plus b squared. Okay, and then I also have the sine of alpha is equal to a, let me make sure, nope, sorry, it's b, okay, b over the square root of a squared plus b squared. And then my cosine of alpha is equal to a over the square root of a squared plus b squared. So, let's fill in all these details. A is a negative 1. Okay, comparing it to my identity, a being with the sine, b being with the cosine. Okay, a being with the sine, b being with the cosine. So a is negative 1 and b would be radical 3. Okay, let's plug those in. That means I'm going to have this as the square root of 1 plus 3. Again, squaring a negative 1 gives me positive 1, squaring a radical 3 gives me 3. So that's the square root of 4, which is simply 2. I now know that the amplitude of this graph is going to be 2. So this is equal to 2 sine of x plus something. I got to figure out what that alpha something is. So moving back here, I'm going to plug all these details in. I know that the square root piece is simply 2, so I'm going to go ahead and write that in there for both these problems. Okay. Next, I need to know what is a and what is b again. Well, I said b was a radical 3 and a was a negative 1. And now I've got to remember, where is alpha such that I have cosine a negative 1 and sine radical 3 over 2. Now I don't have the unit circle directly in front of me, but I can very quickly sketch a graph here. Cosine has to be negative for the x values, so I'm over here in one of these two quadrants. Sine is positive, so I've got to be up here in these. So I know I'm in this quadrant. It's just a matter of knowing which angle measure I'm playing with. Well, I know it's not the 45 that's over here, okay, because that's radical 2 over 2, radical 2 over 2. But remember, increasing in terms of the y's, yes, increasing in terms of the y's. So there's going to be 1 over 2, and it's going to be radical 3 over 2. Sine is radical 3 over 2. So it's going to match up with this one here, meaning it's going to match up with this one here. And if that's all true, that means I'm looking at the angle measure of, looks like 30, 60, 90, 120. Okay, so again, it looks like one more time, 30, 60, 90, 120. And 120 degrees is equivalent to, what is that, 2 pi over 3? Pi over 3 is 60 degrees multiplied by 2, yes. So, and that's the case, this is 2 pi over 3. I now have the equation, again, one more time, knowing that sine of alpha has to equal this, cosine of alpha has to equal this. I can identify that exact angle measure on my unit circle, and there's my alpha value. Okay. To graph this function, I now need to go through all the generic steps. I'm going to go ahead and flip this page over and rewrite this. This is again 2 sine of x plus 2 pi over 3. Let me check that one more time. Yes. So, I have a height of 2. I'm going to go ahead and really quickly sketch that part in. 2, negative 2. I know that generally it looks like this. Here's 2 pi, here's pi over 2, and here's my 3 pi over 2. That point is 0. I have a phase shift of 2 pi over 3. That's negative, so it's shifting in that direction. I'm going to take this first value and subtract 2 pi over 3 from it. So that's going to set me at, this graph is going to be shifting to negative 2 pi over 3. Okay, that's where my 0 point is. Where's my next point? Well, let me take pi over 2. And I'm going to subtract 2 pi over 3 from it. That's going to change these both in terms of common denominator of 6. That's 3 pi minus this one's going to be 4 pi, and therefore I get a negative pi over 6. So my next point actually does still sit on the negative side. And let me check that one more time to make sure I didn't make any mistakes. It's a negative phase shift. Subtract 2 pi over 3 from 0. That's good. Subtract 2 pi over 3 from pi over 2. So yes, my height of 2 is going to be here. Okay, now I'm going to keep this consistent as possible. This is a negative pi over 6. This one here would actually be, if I change it to pi over 6, a 4 pi over 6. It looks like what I'm going to be adding every time is a 3 pi over 6. That should make sense, because what's 3 pi over 6? Pi over 2. And that's my consistent change in this over here graph. So 3 pi over 6 added to this is going to be a 2 pi over 6. 3 pi over 6 added to that is going to be 5 pi over 6. And lastly, the 1, 2, 3, 4, fifth point is 8 pi over 6. Okay, with all those plotted, I'm going to go 0, I'm going to go low, I'm going to go back to 0. With my maximum value being 2 and my minimum value being a value of 2. This is now graphed. Again, if you're not liking this particular image and the way that I did this work, okay, you can always use the table with X, phase shift, and the Y. Okay, you can always use this table, but I'm not going to do that in this video. That completes your lesson 14. If you have any questions, please make sure you jot them down and bring them to class.